Okay, so today we're talking about section 3.2, and it's how are we going to graph an equation. Okay. So the graph of an equation in x and y consists of all points, x and y, the ordered pairs, that make the equation true. Okay. So if we were asked if this point lies on this graph, what we would do is we would substitute the point in. Okay. So our x value here is -2, and our y value is 3. Okay. So is it true that 3 is equal to 2 times -2 plus 1? Okay. The 3 from here, the -2 from here. Okay. Now as we simplify this, we get 3 is equal to -4 plus 1, and we can see 3 equals -3. No, this is false. So then we make a conclusion, no, -2, 3 does not lie on the graph. Alright, let's try this one. Let's see if -3 and -5 does. Okay. In this case, x is -3 and y is -5. So -5, does that equal 2 times -3 plus 1? So we're just asking ourselves that. Okay, so -5, we get -6 over here plus 1, and then we see -5 equals -5. So we say yes, this point, -3, -5, does lie on the graph. Okay, but there's an infinite amount of points to pick, and so this is a very haphazard way to go about graphing a line. A better way to go about graphing it is to pick some random values for x and see what y comes out. Okay. So, for example now, if y is equal to 1 minus 3 times x, the first value of x we're going to pick is -2. When we do that, we get 1 plus 6, negative and negative are positive, which is 7. Okay. So that means that we have this ordered pair, -2 and 7. Okay. So here's 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay. So if we can plot that point, and let's label it. You'll need to be labeling everything. Okay. Now we'll go again with 1, -1. So again, y is equal to 1 minus 3 times x, but x in this case is -1. So we get 1 plus 3, now which is 4. Okay. So when x is -1, y is 4. -1, 1, 2, 3, 4. And then we'll label it to make it neat. Okay. And then we'll continue. Y is equal to 1 minus 3 times x, which is 0, which is 1 minus 0, which is just 1. So we have the point 0, 1. Now we continue. Y is equal to 1 minus 3 times x, which is 1, which is 1 minus 3, which is -2. So we have the point 1, comma, -2. And then we'll pick the last one. Y is equal to 1 minus 3 times 2, which is 1 minus 6, which is -5. Okay. So when x is 2, we come down to -5, -3, -4, -5. So here, 2, comma, -5, write in -5 there. This is a table of values, okay, so if you're ever asked to complete a table of values, this is what you're being asked to do. Okay, so what we did is we picked 5 random variables, well, we'll talk about this. We picked 5 values for x and determined what corresponding y came out. Then we plotted these points. And as we see the points, then, we can infer what the rest of the graph looks like. And we can connect the dots. Okay? So there are values for x all in between here. Okay? The graph and y's for them. So we're just sketching this. Okay? And the values will continue on in both directions. Now the question below asks us if there was anything magical about the choice of -2, -1, 0, 1, and 2, okay, that we were given here for x. And there was really no magic about that. These are just nice x values that are right around the origin, so it makes it very easy for us to graph. So the answer to that is no, but it's easy. Okay. Now we've picked 5 points, and that will often be enough. We need to plot 5 points so we can at least see what's happening with the graph. Okay. Now, the next example we're going to do will show us or illustrate that these choices might actually make it more difficult for us, and we should choose some other values. Now, in this one, the values of x that we've chosen are multiples of 3. Okay. So, let's see why we may have done that. So our first one is y. Okay, now here is our graph, 2/3 of x, but x in this case is -6, and we can write it as -6 over 1 since we're multiplying a fraction, and then -4. Okay. Now, when we do this, let's make sure we do our canceling. So 3 goes into -6 -2 times. The -2 times +2 became -4. So that was really nice. Our fraction disappeared. And then we still have the -4, which is -8. Okay. So we get the graph, the points -6, -8. 6, right? 2, 4, 6, -8. 2, 4, 6, 8. Okay, so -6, -8 is down here. And we'll label it -6, -8. Okay. Now we'll go again. Y is equal to 2/3 times now -3. Okay. And since we're multiplying, we can write that as -3 over 1, then -4. Again, we see some canceling. 3 goes into -3, -1 time, and -1 times +2 is -2. So again, we got rid of the fraction. Now -4 is equal to -6. Okay. So at -3, we have the point -6, or the y value -6. So -1, 2, 3, and then 1, 2, 3, 4, 5, 6. We come over to there, and we will label this point -3, -6. Now we continue. Y times 2/3 times 0 -4. Well, this is nice because 0 is going to make the 2/3 go away. We'll just get 0 minus 4, which is equal to -4. Okay. So at 0, we have the point -4. So this is the point 0 minus 4. Okay. And we'll continue with 3. So y is equal to 2/3 times 3 over 1 minus 4. Okay. And again, we see some canceling. 3 goes into itself 1 time. So then 1 times 2 is +2 minus 4 is equal to -2. So we get the point 3, -2. Okay, so 1, 2, 3, 1, 2. 3, -2. Okay. And now we have the last one. Y is equal to 2/3 times 6, and we'll write 6 as 6 over 1, minus 4. Again, we see some canceling. 3 goes into itself once and into 6 2 times. 2 times 2 is 4. Then minus 4 is 0. So we get the point 6 comma 0. So again here, when we multiplied, the fraction was gone. And we have the point 2, 4, 6. So this is the point 6 comma 0. Okay. And now we can connect the graph. If you need to, just make that a little bit bigger. Okay. Make that one a little bit bigger too as well. Okay. So this is what I'll expect on your exams if you're asked to make a table of values. This is what you're being asked for. I'll expect you to label your points as ordered pairs, and I expect you to include arrows as well, because this indicates that this graph is continuing on. Okay. So now we can look back, and why did we choose the x values to be multiples of 3? When we did that, notice what happened is that our fractions went away. Okay. And the reason why that is because the denominator here was 3. So any multiple of the denominator will cause the fractions to cancel. Okay. So that's always a good technique to use. Okay. All right, let's do this other one now. Okay. Again, here we're just back to picking basic values. There's no denominators for us to work with. Okay. So let's start plotting, picking points and figuring out. Okay, so y is equal to negative 2. We square that and add 3. Okay. Well, negative 2 squared is positive 4 plus 3, which is equal to 7. Okay. So here's negative 2, 4, 6, 8, so here's 7. And we'll label that point negative 2, 7. Okay. Now we'll pick negative 1. So y is equal to negative 1 squared plus 3. Negative 1 squared is positive 1 plus 3, and that equals 4. So at negative 1, we have to go up 4. Okay. So this is the point negative 1. No. Yes, negative plus 3. Negative 1, 4. Okay. Alright. Now we continue. Y is equal to 0 squared plus 3. Well, 0 squared is just 0 plus 3, which equals 3. Oh, I should fill this one in. So this was negative 1, 4, and this is 0, 3. Alright, 1, 2, 3. Okay, so clearly this graph is not following in a nice straight line like this one is. We have some type of curve happening here. Okay. But let's continue and see what happens. And now y is equal to 1 squared plus 3. Well, 1 squared is 1 plus 3 is equal to 4. So at positive 1, we also have this point 4. 1 comma 4. So the function values here are the same. Okay. The y values. And lastly, we pick y is equal to, let's see, so at 1 we had 4. Okay. Now if y is equal to 2 squared plus 3, we get 4 plus 3, which is again 7. So at 2, we come up again to 7. Okay. So this is why we pick 5 points, so we can really see what's happening with the graph. And what we can see is happening when we connect these dots is that this is curving, and it will continue to curve up. Okay. And that this is curving, and this is also continuing to curve up. Okay. The next one, if I picked 3, I would get 3 squared plus 3, so 3 squared is 9, plus 3 would be 12, so it would be way up here. The same would happen at negative 12. Okay. This is a graph that's known as a parabola. And notice the difference here. The x has an exponent of 2. Okay, so that causes squaring, and that's forced everything to stay positive. Alright, so that's how you graph that. Now, this is also an equation. X minus 2y is equal to 5. That's a perfectly acceptable way to write an equation. Okay? Notice it's not hasn't been solved for the variable. Okay? So we could solve this thing for y, but in this case it's easier to solve for x because I just have to add the 2y to both sides to get 2y plus 5. Okay. Now let's evaluate for these values of y. So x will be equal to 2 times negative 2 for y plus 5. So that's negative 4 plus 5, which is a positive 1. So when x is 1, y is negative 2. Okay, now we'll try this one. So x is equal to 2 times y, but we've picked y to be negative 1, plus 5, which is negative 2 plus 5, which is 3. Okay, so when x is 3, y is negative 1. Here for 0, we love 0, it's the easiest one. 2 times 0 plus 5, well, that's just 0 plus 5, which is 5. Okay. So when x is 5, y is 0. Okay. Now, x is equal to 2 times y, in this case we'll say 1 plus 5, which is 2 plus 5, which is 7. And finally, x is equal to 2 times 2 plus 5, which is 4, plus 5, which is 9. Okay. Alright, so let's see here. We need y values that go from positive 2, 1, 0, negative 1, and negative 2. Now the x are the odd intervals, so we could call this one 1, this one 3, this one 5, this is 7, and this is 9. Okay. Alright, let's try and graph this now. 1, negative 2. But always label 1, comma, negative 2. 3, comma, negative 1. 5, comma, 0. 7, comma, positive 1. And 9, comma, 2. Okay. Alright, so now this should be a straight line. I think this one needs to come down just a little bit more. I think it was up a little high. That's okay, we've labeled it, and now we can connect the points. Remember adding arrows at both ends. Again, this is what we call linear. It is a line, and notice that there's no squaring involved anywhere with the variables. Okay, so the above graph is just fine. But it really is a good idea to graph your x-intercepts and your y-intercepts whenever possible. Okay? Now, the x-intercept is a point that lies on the x-axis. And the y-coordinate of this point is 0. So our table would indicate here that y is 0. So the point 5, 0 is our x-intercept. Now we don't know what this y-intercept is here. It's going to come down this graph will. So it's a point here. I don't know what it is. Okay? But if it's a y-intercept, okay, then x has to be equal to 0 because I'm not moving left or right. It has to be there. So let's plug x equals 0 into the function, okay, into our graph of our line. X minus 2y is equal to 5. Okay, so if x is 0, we get 0 minus 2y is equal to 5, or that negative 2y is equal to 5, or that y is equal to negative 5 halves. So that means our y-intercept is 0, comma, negative 5 halves. Okay, so that's this point here. 0, comma, negative 5 halves. Okay, now let's keep graphing. Okay, so they want us to consider this equation, x squared minus 3x minus 4. Okay, so notice that we have a variable, or not a variable, an exponent attached to this variable, and the exponent is 2. Okay. We can think about there being an exponent here as like to the first power. But okay, so this could cause us some interesting things. All right, we're going to let x equal, as instructed, negative 2, negative 1, 0, 1, and 2. Alright, so now let's do some work for that. Okay, I guess I'll write it up here. So y is equal to negative 2, we square that, then we subtract off 3 times x, which is negative 2, and then we'll subtract 4. Negative 2 squared is positive 4. Negative 3 times negative 2 is positive 6, and then we subtract off 4. 4 minus 4 is 0, so we're just left with 6. Okay, so when x is negative 2, y is positive 6. Now let's do negative 1. Y is equal to negative 1 squared minus 3 times negative 1 minus 4. Negative 1 squared is positive 1. Negative 3 times negative 1 is plus 3 minus 4. 1 plus 3 is 4. 4 minus 4 is 0. So when x is negative 1, y is 0. Okay, now 0 is going to be really easy, right? Y is equal to 0 squared minus 3 times 0 minus 4. Well, that's real easy. This is 0 minus 0 minus 4, which is just minus 4. Okay. So anytime you have that, that's just the constant here. Okay. All right, now we'll do the positive one. So y is equal to 1 squared minus 3 times positive 1 minus 4. 1 squared is 1. Now, negative 3 times positive 1 is minus 3 minus 4, which is 1 minus 7, which is negative 6. And lastly, y is equal to 2. We square that. Minus 3 times 2 minus 4. 2 squared is 4. Minus 3 times positive 2 is minus 6 minus 4. 4 minus 4 is 0, so we're just left with minus 6. Did I do that right? Two squared is 4. Minus 3 times positive 2 is minus 6 minus 4. 4 is minus 6. 1 squared is 1. Minus 3 minus 4. Okay. Alright, so let's see what this is going to look like. Okay. Let me just check something out here. Yeah, okay. This is good. Alright, so now, where are we at here? Let's call this -2, and this -1, and this 1, and this 2. And we need to go up. Okay, so let's call this 2, 4, and 6. So -2, -4, -6. Okay, so at 2 we'll get +6. At 1 we get -1, we get 0. At 0 we get -4. At 1 we get -6. And at 2 we get -6. Okay. Now this is not really clear to me what's happening here. Okay. Because if I was to connect this, I see a nice curve happening here, but then all of a sudden it goes like this. And that's just odd behavior for a graph to do. Right? So I want to take a point in between here and see what's happening. Okay, so let's find the point 1 1/2, right, which is 3/2. All right, so where can I do this? Okay. I guess up here. So y is equal to 3/2 squared minus 3 times 3/2 minus 4. Okay, now 3/2 times 3/2 is 9/4. Okay, so this is 9/4. Okay, and this is like 3/1. So this is minus 9/2, and then minus 4. Okay, like over 1. Now, I'm subtracting fractions, so I need to get a common denominator, which is 4, so I'll multiply this by 2 and this by 2, this one by 4, and this one by 4. So this is equal to 9, okay, all this is over 4. 9 times 2, that's negative 18, and 4 times 4, that's negative 16, which is equal to, okay, 9 minus 18 is minus 9, and then we're subtracting off another 16. So if we add this, that's 25, but in the negative direction. Okay, so negative 25/4. Okay, so we want to know how big this is, alright? So 25/4, how many times does 4 go into 25? Well, 6 times 4 is 24, and I have a remainder of 1. Okay? So 25/4 is negative 6 1/4. Okay? So that means I'm just down here. So at 3/2, the y value is negative 25/4. Alright, now this is also pretty interesting here. Notice that these 2 points are directly across from each other. Right, so the distance here was 1 and 2. Okay. What if I look at 0 and at 3? Will there be another point that's here? Let's try that. I'm just going to work down here and then I'll get a new sheet for this one. Okay, so let's try and find out what happens when x is equal to 3. Okay. In this above equation, then y is equal to 3 squared minus 3 times 3 minus 4. So this is 9 minus 9 minus 4. So y is equal to 0 minus 4, which is just negative 4. And so it's true, here at 3, there's a point directly across from here, 3 comma negative 4. Okay. And this is going to be true for the rest of the points too. Here at 4, we'll get 4 comma 0. And then there's one over here okay, so we went one more, so this would be 5, and up here it would be back up at 5 comma 6. Okay, so these points should be directly across from one another. Okay. And that's one of the characteristics. Remember, we are in a formula here that has an x squared, so this is a parabola. Okay. And so it's that U-shaped kind of pattern, and there are points directly across from each of these. Okay. That's because parabolas have something we call symmetry, which we will learn about next semester in college algebra. Okay, but for now, let's keep plotting our points. And now this one, notice we have a y squared instead of an x squared. So let me get a different sheet of paper so we can do this. Okay, so we have x minus y squared is equal to negative 4. Okay. And the first thing we're directed to do is to find the x-intercepts and the y-intercepts. Okay, so find the intercepts. Alright, so for an x-intercept, okay, that if you're on the line here, you can't go anywhere in the y. So for the x-intercept, we let y equal 0. And for a y-intercept, and now you're on this line, okay, to do that you can't go anywhere left or right in the x, so you have to let x equal 0. Okay. So now let's use our equation that we're given to try and find this. Okay, so for an x-intercept, we're going to let y equal 0. So x minus 0 squared equals minus 4. And now we'll solve for x. This is very easy. X minus 0, 0 squared is 0, minus 4. X minus 0 is just 0, so x is equal to negative 4. Now this is not our x-intercept. The x-intercept is the ordered pair, negative 4, comma 0. Now let's find the y-intercept by letting x equal 0. So we get 0 minus y squared is equal to minus 4. Well, 0 minus y squared is just minus y squared is equal to negative 4. Okay. I'd like to get rid of this negative, so let's multiply by a negative 1. Okay. So we'll get y squared is equal to positive 4. And now we can take the square root to get y is equal to plus or minus the square root of 4. And don't forget your plus or minus. And plus or minus the square root of 4 is 2. So when we did this, we actually got 2 values for y here. Okay. And so that leads to 2 different ordered pairs. In both cases, I let x equal 0, but one of them is the positive 2 value, and the other is the negative 2 value. Okay, now, then we're instructed to solve for x. Okay, well that's really easy. X minus y squared is equal to 4. If I want to solve it for x, I just have to add that y squared to both sides. Get 4 plus y squared. Okay. So now that we're instructed to make a table of values, and this time they want us to choose y using our basic negative 1, negative 2, negative 1, 0, 1, and 2. Okay, So x is equal to 4 plus negative 2 squared. So x is equal to 4 plus negative 2 squared is 4 is equal to 8. Okay. So x is equal to 8. Now with the negative 1, x is equal to 4 plus negative 1 squared is 4 plus positive 1, which is 5. So we have 5 comma negative 1. Okay, 0. This is going to be really easy. If you let y equal 0, you just get x is equal to 4. Okay. Now with 1, x is equal to 4 plus 1 squared, which is 4, plus 1, which is equal to 5. Aha! The same thing's happening here. Okay. And we also have the last one at 2. 4 plus 2 squared is equal to 4 plus 4, which is equal to 8. And again, we have some similar values. Okay. That's because when you square anything, it stays positive. Okay. Alright, now let's put all of this together and graph it. Okay, so x needs to go from negative 8 to positive 8. Okay, so if this is negative 4, this is negative 8, positive 4, positive 8. We also need 5 in there, and negative... Yeah. And then, let's see, y goes from positive 2 down to negative 2. Okay, so what do we have here? We also have a negative 2. Okay, so our x-intercept is at negative 4, 0. Label that, negative 4, 0. And then our y-intercepts happen at 0, 2, which is way up here. And 0, negative 2. Okay. Now what else do we have? When x is 8, we have both negative 2 values, and when x is 8, it's also positive 2. When x is 5, we have a negative value here, 5 comma negative 1, and 5 comma positive 1. This is looking very bizarre to me, people. And x is equal to 4. Equals negative 4. This 4, hang on, I'm just checking my word, positive 1. And let's see here, if we have x minus y squared is equal to negative 4, then this is what the graph should look like. So I'm confused about where these points come from. So if we find the x-intercept, we let y equal 0. So x will be equal to negative 4. Zero minus y squared. We let x equal 0. Did I copy this right? That becomes positive 4, so that's plus or minus 2. This is bizarre. Okay. Let me come back to this. Let's finish this. So we've got some more to do. And if we, okay, let's do some more. So for example, then here down at below, some graphs won't have an x-intercept. So for example, this graph never crosses the x-axis, so that's fine. It does have a y-intercept. Now this graph doesn't cross the x or the y. That's fine as well. It can happen that way. Okay. Now with this one, so y is equal to, if I was to solve this for y, I would take plus or minus the square root of x minus 1. Okay, so this is a square root graph, okay, but it has two portions. Also with this graph that we had here, that we were just looking at, okay, the equation for this was given as x minus y squared is equal to negative 4. So if I solve this for y, I would need to add 4, and then add the y squared as well. Okay, so we get y squared is equal to x plus 4. This graph just is making me more and more crazy. Okay, the square root of plus or minus x plus 4 equals 0. No, it doesn't. It equals y. Sorry. Oh, here's the problem, you guys. Right here. X minus y squared is equal to negative 4. So what does that change? Then this becomes... Okay. Alright, let's try this again while we're at this. Okay. So x minus y squared is equal to negative 4. So x is equal to y squared minus 4. There we go. Alright, let's try again now. Okay. Okay, so y is equal to negative 2, negative 1, 0, 1, and 2. And now we plug it in. Okay, so x is equal to negative 2 squared minus 4, which is 2 squared, which is 4, minus 4, which is equal to 0. Now, x is equal to negative 1 squared minus 4, which is 1 minus 4, which is negative 3. X is equal to 0 squared minus 4 is equal to 0 minus 4, which is equal to negative 4. Okay, this is making much more sense now. X is equal to 1 squared minus 4, which is 1 minus 4, which is 3. And x is equal to 2 squared minus 4, which is 4 minus 4, which equals 0. Okay, so these are the ordered pairs: 0, negative 3, when x is 0, negative 4, minus 3, and 0. Okay. Alright, so when we graph this, then, okay, from positive 2 to negative 2. Okay. Then we also need out here negative 4 and negative 3. Okay. So when x is 0, y is negative 2. Okay, so 0 comma negative 2. When x is negative 3, let's make sure I've done this right. When x is negative, when y was positive 1 squared minus 4 is negative 3. So when x is negative 3, y is negative 1. When x is 4, y is 0. When x is negative 3, it's also a positive 1. And when x is 0, it's also, I did the, good grief you guys, positive 2 and the negative 2. Okay. Whew. Alright. Now when we connect the dots. Okay. It looks like this. There we go. Okay. So these are our this is our x-intercept, okay, that we found from before. And we have 2 y-intercepts here. And notice that this occurs because we have a y squared in the equation. X is equal to y squared minus 4. Okay, so we have 2 y-intercepts, 0, positive 2, 0, negative 2, just like we found from the formula. And our x-intercept is negative 4. Did we do that right? So x-intercept, we let y equal 0. X is equal to 0 squared minus 4. So x is equal to negative 4. So we have a y-intercept, an x-intercept of negative 4 comma 0. Check. Bam. Okay. Whoa. Okay. Let's move along. All right. Where were we at? We were at we were looking at this equation. Okay. So if you solve this, you'll get plus or minus x minus 1. Okay. And I guess that's why I went back to show you this, that if we solved for this one, for y, we would get x plus 4 is equal to y squared. And now solving for y, plus or minus the square root of x plus 4 is equal to y. So what I was trying to point out here is that this is really 2 branches. This graph, the positive branch, looks like this. And then the negative branch comes here, okay? And together they form a parabola that lays on its side. Okay? And we'll see this occur again later on and find out that this is, when we talk about functions, that this is not a function. Okay? So the same thing's going to happen here with this plus or minus. It's going to actually look, we have, let's see, if we let y equal 0, then you'll square it, so x will be equal to 1. Okay, so it's going to have this point 1 comma 0 here, and the plus here will come up this way, and this minus will lead you to the bottom half of it. Okay, so in this case, this is a graph that doesn't have a y-intercept. So you don't have to have x and y intercepts, okay, to a graph. Could happen. Okay, more plotting, more plotting. 3 more to go. We have the absolute value of x minus 3. Okay, let me focus this. There's no fractions for us to deal with, so we may as well just pick our basic negative 2 to positive 2 values. Okay. So if we plug this in, we get the absolute value of negative 2 minus 3. That's equal to the absolute value of negative 5, which is equal to 5. And we'll just continue. Negative 1 minus 3, that's equal to the absolute value of minus 4, which is positive 4. The absolute value of 0 minus 3, well, that's just the absolute value of negative 3, which is positive 3. The absolute value of 1 minus 3, that's the absolute value of negative 2, which is positive 2. This is the absolute value of 2 minus 3, which is the absolute value of negative 1, which is equal to positive 1. Let's keep going and pick a few more points. If we let 3, we'll get 3 minus 3 is equal to the absolute value of 0, which is equal to 0. If we pick 4, we get the absolute value of 4 minus 3 is equal to the absolute value of 1, which is 1. Okay, so let's graph this. Okay, so we're going from 5, 3, 2, 1. Okay, so at negative 2 we're at 5. At negative 1 we're at 4. At 0 we're at 3. At 1 we're at 2. At 2 we're at 1. At 3 we're at 0. Okay, so if we had just stopped here, we could probably be very well convinced that this graph was just a line. Okay. But this absolute value is going to throw some kink in that. Because when we get to 4, now we're back up here at 1. And it would turn out that if we kept going, we'd go to 5, 2. That these points would again be next to each other. And this is a characteristic of absolute value graphs. They look not like a parabola, but like a straight line that has been bent to keep the values positive. Okay. So sometimes, if it's not linear, you're going to need to pick more points. This absolute value graph is one that is deceiving. Okay. Now here's the square root of x. Okay, so this is what I was talking about earlier, but it's a much simpler version of it. Alright, now we know that we can't take the square root of a negative number, so I'm not even going to worry about these negative 2's and negative 1's. So the first one we can start with is 0. And then I want to pick values for x that are perfect square roots to make it easier. So I know the square root of 0 is 0. If x is 1, I get the square root of 1, and the square root of 1 is 1. If I let x equal 2, then I get the square root of 2, and that's irrational. So let's avoid that. The same with 3, we get the square root of 3. But if we pick 4, then the square root of 4 is 2. If we picked 9, then the square root of that is 3. We could pick the next one, which is 16, and the square root of that is 4. So it turns out, now here you're going to want to put a heavy circle, and it's this graph that increases like this. Okay? And now I'm going to label these points to make it true. So this is 1, 1, say this is 4 comma 2, this is 9 comma 3, way out here is going to be 16 comma 4. So by labeling the points, I made it true. Notice if I tried to hash that out, it was going to be a really big mess. Okay. Now, there's also horizontal and vertical lines that we have to talk about. Alright, so if the equation is y equals 2, we could pick our values, negative 2, negative 1, 0, 1, and 2 for x. But notice there's no x in here to even substitute in. So we don't care what value of x it is. Y will always be 2. Okay, that's what this equation means. And so if I was to graph that, here's the point 0, 2, 1, 2, 2, 2, etc. Negative 1, 2, negative 2, 2. And now if I connect these, it turns out that this is a horizontal line. The equation of this line is y is equal to 2. Okay? So for all values of x, y is equal to 2. Okay. Now if we come over here, this says we can't pick any values for x. X is going to be negative 3. Okay. Well, what is y going to be? Well, there is no y. So what this is saying is that for all values of y, you can pick whatever values you want. Negative 2, negative 1, 0, 1, 2, it doesn't matter. X stays constant at negative 3. So here's the point negative 3, 2. Here's the point negative 3, 1. Here's the point negative 3, 0. Negative 3, negative 1. Negative 3, negative 2, etc., etc. So for all values of y, x is equal to negative 3. Okay? The equation of this line is x is equal to negative 3. And this is going to be true, okay? So if you have an equation of the form x is equal to a, where a is a constant, you're going to get a vertical line. And if it's y is equal to b, where b is a constant, right, a real number, then you're going to get a horizontal line. Alright, this will get you through your exercises. This number 13 could give you some trouble. That gave me a little bit of trouble when I did it in the notes. That's where y squared is at. Alright, let's try and do that one together. Okay. So y squared plus 1/2 of x equals 0. Okay. We need to graph this equation and find all x and y intercepts if they exist. Okay, so for our x-intercepts, we let y equal 0. Okay. And for a y-intercept, you let x equal 0. Okay, so if we let y equal 0, we get 0 squared plus 1/2 x equals 0. Or that just 1/2 x equals 0. I can multiply by 2 over 1 to get rid of this. Okay. So I'm just left with x, but 0 times anything is 0. Okay. So that means our x-intercept is the point 0, 0, which is the origin. Okay. At this point right here. Now notice the thing about the origin is that it is both an x-intercept because it crosses the x-axis and a y-intercept because it crosses the y-axis. So when we do this, we should get the same coordinate. Okay, so if we let x equal 0, we'll get y squared plus 1/2 of 0 equals 0. So that y squared plus 0 equals 0, or just y squared is equal to 0, so that y is equal to plus or minus the square root of 0. Y is equal to plus or minus, now the square root of 0 is 0, and 0 is neither positive nor negative, so it's just y equals 0. So we do get the point 0, comma 0. Okay, so we're good there. Okay, now we're supposed to make a table of values. Now I'm just going to solve this for y. I know we solved it for x, but let me do it both ways. So y squared is equal to negative 1/2 of x. So y is going to be plus or minus the square root of negative 1/2 of x. Okay. Okay. Since we're not going to be able to take the square root of a negative number, the values for x that I pick need to be negative. Because then a negative times a negative would become positive, and then I can take the square root of that. Okay. Now, we also want to pick multiples of 2. So if x is negative 2, I get plus or minus the square root of negative 1/2 times negative 2, and that's equal to plus or minus the square root of positive 1, which is equal to plus or minus 1. Okay? So this means I get two ordered pairs. Negative 2, positive 1, negative 2, minus 1. Oops, sorry. Okay, so I'm picking the negative 1/2 times negative 2 becomes positive 1. So we have plus or minus the square root of 1. The square root of 1 is 1. And I have the plus or minus. So when x is negative 2, I have 1. And also when x is negative 2, we have negative 1. Okay. Now what I would like in here for the next one is plus or minus, I would like it to be plus or minus 4. Okay, so negative 1/2 times x to be equal to 4. Okay. Now I can solve this by multiplying by negative 2 over 1. Negative 2 over 1 is just 2. This becomes positive x, and this is negative 8. Okay, so if x is negative 8, then I can plug that in. Negative 1/2 times negative 8 over 1. The negative and negative become positive, and 2 goes into 8 4 times. So we get plus or minus the square root of 2. And from here, I'll also get 2 more points, which is negative 8, positive 2, and negative 8, negative 2. And then that will be 5 points because we have the 0 and the 0. Okay, let's try and graph this. Okay, x is in the negative direction. Okay. X goes out to negative 8. Let's call that negative 6, negative 4, negative 2. And again, we'll go from positive to negative 2. Okay. So when x is 0, y was 0. So that was our point here, 0, comma 0. If x was negative 2, we had plus or minus 1. So negative 2, 1, and negative 2, negative 1. And the next one was when x was negative 8, we got positive 2. And negative 2. Negative 8, negative 2. Okay. So now when we connect these graphs, we still get a parabola. It's just flipped on its side, and now it's taking off towards negative infinity. Okay, I think you should be able to do the rest of your homework okay. Send me an email if you have a question.